All right. Hello, everyone. Thanks for joining. In this session, I will be discussing about one of the most common issues in SQL Server, and that is TempDB contention. This is one of those performance problems I have learned the hard way in my earlier years as a database administrator. So I want to make sure you have all the right tools to handle this smoothly if this were to occur on your production servers. And about myself, I have been working as a SQL database administrator for 10 years now. I love internals of the SQL Server engine. I can roll my sleeves up and dive into the engine internals for hours. And I work a lot on AWS EC2 instances with SQL Server installed on them. I'm an AWS certified solutions architect, and I also won an award at work that's Rookie of the Year. So that's about me. And then I have 2 kids, and my husband equals 3 kids. That's what I usually say. But yeah, so I mean, he's watching the kids now. So I don't think I should be making any jokes on him right now. All right. So that's about me. Going into the topic. So today's agenda will be I will be discussing about how this contention on TempDB occurs, what are the different types, how to identify the contention, and what are the different ways you can address and resolve them. So what is the need about this session today? When there are many processes on the SQL Server, obviously there will be some slowness. So to troubleshoot that slowness, first you need to understand how that slowness occurs. And most of the times we see that slowness occurs due to the contention on TempDB. So once you understand how to address and resolve that contention, then you will know to address and resolve the slowness on the system as well. And similarly, on any production system, you have thousands of concurrent transactions running. You really need to manage them all effectively so contention does not occur. But first, for you to manage them all, you need to understand how that contention occurs. Then you will know, oh, so I need to do all of these so the contention on the system does not occur. So to address these issues, it is very important you understand how this TempDB contention occurs and how we resolve it. At the end of the session, you will know that, yes, we identified slowness and resolved it, and also we managed all the concurrent transactions, right? And so why is there contention on TempDB? Why are we talking about this contention on TempDB, but not on the other user databases at the moment? If you take any SQL Server, you have many user databases, and there are certain number of transactions running on the user databases. But if you take TempDB, you have 10 times the workload or even 100 times the workload on TempDB compared to any other user databases. That is because you have inserts, updates, and deletes on temp tables or any temporary objects running on TempDB. There is only one TempDB in that whole SQL Server instance. This TempDB is shared by all user connections, and for any temporary object operations, TempDB is used. From any of the user databases, you run any temporary table object operations, TempDB is used. Not just that, hash joins, merge joins, sorts, or variables, or even version store when you use, read committed, snapshot isolation level. For everything, TempDB is used. You will see the workload getting 10 times or 100 times more on TempDB. And no wonder contention occurs. So that is why we are discussing about contention on TempDB today. We have 2 most common types of contention. That will be object allocation contention, which is of the DML type, and metadata contention, which is of the DDL type. We will be discussing both of these contention types in detail. And there is also a third type of contention called temp table cache contention, but it's usually a rare form of contention, and it's not easy to do a demo on it. We will need Microsoft involved to resolve it. So that's what Microsoft has said. People, like, if you see those pin locks or the third type of contention that I'm talking about, there's nothing we could do. So I felt like, okay, I mean, what's the need to show that third type of contention, right? Anyway, we won't be able to resolve it. So I'll just show you these two types of contention that we see in 99% of organizations and how to resolve it. First one, object allocation contention. So when you run any inserts, updates, or delete transactions on the temporary objects, you know that TempDB is used. So when those DML operations run, to allocate those objects onto the data pages, SQL Server uses three special pages called PFS, GAM, and SGAM pages. With the help of these three pages, SQL Server can allocate the objects onto the data pages. What these three pages do, these three special pages, is it tells SQL Server which page is free, how much of a page is free, and which page is already allocated. So these three pages have that, special power in them to tell the SQL Server where you should go allocate your object onto. Like, for example, yes, go allocate the object in page 5, or go do it in page 25, page 100. So these three pages, they can tell the SQL Server where the objects need to be allocated. So when you have these DML operations running, those operations, they need to get a latch onto these three pages. Only then it will know which page it can go get allocated. Under normal circumstances, you have some amount of inserts, updates, or deletes running on temporary tables. They can easily get a latch onto these three pages and finish the operation. But if you see on critical OLTP systems where you have too many operations running, now those operations are waiting to get a latch onto these three pages. Then contention occurs. And this contention occurs on those three pages. Because now all those operations are waiting in line one by one to get the information of which page is free or which page that object should go to. So if you see, whenever you have too many operations, now they're all waiting in line, causing contention on PFS, GAM, and SGAM pages. So to allocate an object, these operations are waiting in line to get a latch, causing contention. That's why it is called object allocation contention. And if you see what those three special pages, PFS, GAM, and SGAM are. So PFS page, internally, if you look at the page, this is how it looks like. It has the information of allocated, like file ID and page numbers, and it has allocated, not allocated, 100% full, 0% full. This PFS page tells you which page is how much percentage full. And similarly, if you look at GAM or SGAM pages, it will again tell you which page is allocated or not allocated. And this is the reason those operations, they need to get the latch onto these PFS, GAM, and SGAM pages so they know where they can go allocate those objects into. And if you see this picture, let's call it tempdb.mdf, you see how all those operations are hitting on the data file to get a latch onto PFS, GAM, and SGAM, and that's causing contention. And in one data file, you can also have multiple PFS, GAM, and SGAM pages. And I can talk about hours about those three internal pages, but that's not the scope of the topic today. But if you are interested in reading about it, feel free to go ahead and check the blog post I've written about what these three pages are, what do they do, and how many times they repeat in a data file, and many more things like that. Okay, but the key concept that you have to understand is when you have too many DML operations running, they need to acquire a latch onto these three pages, and that causes contention. Okay, now that we know how this allocation contention occurs, let's see how to identify it. In the demo shortly, I'll be showing you, how this occurs and things like that, but I just want to grab a screenshot here and explain what it will look like when you actually see that allocation contention. So when you run the script to find out the contention, you will see something like this. The wait type will be page latch. And when I say this, I also want to mention, please don't get confused page latch with page IO latch. We have two wait types, page latch, page IO latch. Page latch is the contention that we are interested in right now in regards to TempDB. because that means latches on the pages. So page latch, that's the one we are interested. Page IO latch is completely different. It's about storage, to get the pages from disk storage to memory. So let's not talk about it, and don't get confused about page IO latch. All right. So the only wait type we are interested is page latch. So when you see page latches on the wait resource, let's decode this. The first number is the database ID. Database ID 2 is always TempDB on any SQL server. And the next number is the file ID. You don't have to worry about the file ID numbers. It just, if you have 12 files, then you might have any number anywhere between 1 to 12. And the third number is important because it is the page number. So 1, 2, and 3 are always PFS, GAM, and SGAM pages, and also multiples of 8088 or 511232. You don't have to memorize any of these because we also have what page type this page is. In this case, we know that 2 is GAM page. So it tells you 2 is GAM page. So what you need to remember is when you see page latches on database ID 2, which is TempDB, on GAM page or PFS or SGAM, then you know it is allocation contention. So 3 things here: page latch, on TempDB, on PFS, GAM, or SGAM. When you see these 3 things, then you know it is allocation contention. But instead of PFS, GAM, SGAM, if you see any other pages, then that is not allocation contention. So that's important to remember. All right. So now you know how to identify it. Let's see how to resolve it. So we have this data file, multiple transactions are hitting on that data file, waiting to get a latch onto PFS, GAM, SGAM pages. In order to reduce this contention, if we have more PFS, GAM, SGAM pages, then this contention can be reduced because now all those transactions are waiting to get a latch onto PFS, GAM, SGAM. So having more of those pages is the key idea here. Once you have more PFS, GAM, SGAM pages, then contention will be reduced. Now the point is, how do you get more PFS, GAM, SGAM pages? Create more data files. That's the point. So that is why we have always been creating more data files for TempDB, because you will get more PFS, GAM, and SGAM pages. For one data file, you will have at least a minimum of 1 PFS, GAM, SGAM pages. And depending upon the size of the data file, you can have more PFS, GAM, SGAM pages. But the point here is, for every file, you have at least 1 PFS, GAM, and SGAM pages. All right. So earlier we had 1 file. Now we have 4 files, which means you have 4 sets of PFS, GAM, and SGAM pages. Now all those transactions can spread across the multiple data files, and that reduces contention. So that is why we have always been adding more number of data files to reduce the contention on TempDB. And it is important you understand that this is allocation contention. This will only resolve the allocation part where you have that contention on PFS, GAM, SGAM pages. That is why I said it is important you understand the page latches on these 3 pages. If you see the page latches on any other page, don't add the data files. It is not going to help. Only for PFS, GAM, SGAM pages contention, you add more data files, and that will help reduce the contention. And not just that, there was also an enhancement in 2017, SQL Server 2017, where the allocations not only round robin across the files, they also do within the files. I'll show you that now. So you see allocation 1 goes to PFS data file 1, and then 2 goes here, 3 and 4. And then 5 comes down back here, and 6, 7, and 8. So when it round robins across the files and also within the files, and that helps in reducing the contention even more. So that's an enhancement they did. So the point here, the key point here that you have to understand in resolving this allocation contention is have more PFS, GAM, SGAM pages, and you achieve that by creating more data files. All right. Okay, so this is the thing we just talked about. Round robin across the data files and PFS pages will reduce this contention. And how many data files should you be creating? Always create new data files in sets of 4 or 8. Initially start with 4 data files of equal size, and it should also be the same size as the existing files. Imagine you already have 4 data files, each of 1 gig. Then create another 4 data files with the same size, 1 gig each, and it has to be the same with the existing size too. Okay, so that's how you create. Now the transactions can spread across, and that will reduce contention. And not just that, the same size we just talked about, and not just that. And when you add the new data files, see if you can restart the service. Imagine if you are in the maintenance window or downtime or during the weekends, go ahead and restart the service, because that will help in having all TempDB data files of equal size. Because when you restart the service, TempDB gets started from scratch. So the old existing data files and the new data files that you just created, everything will be of equal empty space. When they are of equal empty space, SQL Server can follow the round robin algorithm. When it follows the round robin algorithm, you have contention reduced even better. But if we have unequal sizes, if you don't create them with equal sizes for some reason, what happens is SQL Server follows proportional fill algorithm, which means whichever big file you have, it has more empty space, then all the transactions will be hitting on that big file, causing a hotspot, which is exactly what we don't want. That is why you always create files with equal size, so SQL Server can follow the round robin algorithm, and if possible, restart the service. But if you're not in the maintenance window, you're in the middle of business day, that's fine. You don't have to restart the service. For a minute or two, it will take time to make all the files of equal empty space, because it will be hitting just the new files for a couple minutes, but then everything will get equal and it is fine. So it's just an advantage that you could take if you're in the maintenance window. All right. So the point here is create additional, once you see this allocation contention, create additional data files, either in numbers of 4 or 8, and create them with equal size, same as the old files. And if you see version wise, in versions 2016 or older, you had this trace flags 1117 and 1118, very popular ones that helped in reducing the contention. But from 2016 version and onwards, you don't have to enable these trace flags because they're already on by default. That comes with the engine. And on 2019, if you see, if you recall, we had contention on PFS, GAM, and SCAM page. So they addressed the contention on PFS page in 2019 version. How they did that is, that part is very interesting, because you remember how those operations are waiting to get a latch. So now those operations, they don't have to wait in line anymore to get the latch, because all those exclusive latches or the update latches have been updated to a shared latch. Now all those operations can share the latch onto that page. So there is no contention on PFS page anymore starting 2019. You will still see GAM and SGAM page contention on 2019, but you will not see PFS page contention. So one part is resolved. And on 22, they applied the same concept and resolved contention on GAM and SGAM pages as well. The same thing, they updated all those exclusive latches to shared latches. So all those operations that are waiting to get a latch onto these 3 special pages, they don't have to wait in line anymore. They can just share the latches among themselves. So that's the best part in 22. Because of this enhancement, there is no need to add new data files in SQL 2022 version. So that's why you hear everywhere people saying, oh, there's no TempDB contention in 22. Well, that part is not true. I'll be speaking about it. But Part of it is true. You will not see allocation contention on 22 anymore. That being said, you still follow all the best practices across all the versions. And if you're seeing a lot of this allocation contention on your older service, I suggest you to migrate to 22, because we have done that, migrated many servers to 22 just to get rid of this allocation contention, and it has helped a lot. You don't need to add additional data files. The server install will automatically give you either 4 data files or 8 data files based on the number of cores you have, and you should be good with the data files that the default server install gives you. You don't need to add any more from 22 version. So that's the best part about 22. If you see this allocation contention, go ahead and upgrade to 22. I know it's not as easy as I say. You should get approvals from the teams and everything, but that's the best part I found in 22 to get rid of this allocation contention on TempDB especially. All right. So I just want to summarize this allocation contention. When you have too many DML operations running, then those operations, they need to get a latch onto PFS GAM pages, and that causes contention. So in order to reduce that contention, you can add more data files in sets of 4 or 8 with equal size, and also the size same as the existing data files. If you have a lot of trouble with this allocation contention, consider migrating to 22, where this contention is resolved by default and no manual intervention is needed. But if you're on versions older than 22, you need to still add data files, check for contention, and then add data files again with equal size. So that brings us to the end of first type of contention. And before we move on to the second, I just want to check if you have any questions.
At this moment, there are no questions.
Okay, that's good. Then let's go ahead with the second type of contention. So the second type is the metadata contention, which is of the DDL type. Earlier, we discussed about DML, that's insert, update, and delete operations. So this is about DDL. When you have any create temp table or alter temp table or dropping those temp tables, then these operations, they need to get a latch on system object pages. Last time it was about DML operations waiting to get a latch on PFS GAM pages. This time in this contention, it's about those create, alter, or drop tables waiting to get a latch on the system objects. It is because they need to insert metadata into these system objects before any of these metadata operations. That's why it needs to get a latch onto these system object pages. Under normal circumstances, you're just creating a few tables or dropping a few tables. But sometimes on very busy OLTP systems, the stored procedures will be constantly creating temp table, dropping temp tables, doing a bunch of stuff. During that time, the server level performance will get impacted because all those operations are waiting to get a latch onto the system object pages, causing contention. So this is called metadata contention because due to the metadata operations, those operations are waiting to get a latch on system objects, which are nothing but metadata objects, causing contention. That's why it is called metadata contention. So these metadata operations causing contention on metadata object pages. So that's why it's called metadata contention. And if you look at the picture here, you see how multiple of those operations are waiting to get a latch onto these system object values table. This is one of the system objects. So they're all waiting to get a latch and causing contention. So this is how metadata contention occurs. This is just one object that's shown here. Actually, there are 12 system objects where there is contention due to these DDL operations. So now you know how this metadata contention occurs. Let's see how to identify it. You will see page latches on TempDB database ID 2. This is the file ID that we don't have to worry about. And this is the page number. And this page number is nothing but sys allocation units. So it will clearly tell you what page this page number is. In this case, it is sys allocation units. Once you see page latches on any system objects, which is nothing but metadata objects, then you know it is metadata contention. In the previous type of contention, we saw page latches on PFS, GAM, SGAM pages. Here you will see page latches on system pages. So that's the key difference between these two types of contention. When you see page latches on PFS, GAM, SGAM, it is called allocation contention, and you add data files to resolve it. When you see page latches on any of the system objects, then we have a different method to resolve this. You don't add data files. Data files will not help in resolving this contention. So that's important to remember. The key difference here is the pages, PFS, GAM, SGAM pages, and here it is system object pages. All right. So now let's see how to resolve it. One of the most important parts here is do not drop or truncate any of the temporary tables. I know we are very much interested in cleaning up our temp tables once we create it in the stored procedure, right? At the end, we'll be like drop temporary tables. So you don't have to do it. It is because SQL Server will asynchronously drop the tables for you. The temp table, SQL Server will do it for you. It is based out of optimistic latching algorithm. I'm not going to go into the details of that algorithm, but all you need to know is do not explicitly drop your temporary tables at the end of the session. You don't need to clean up. SQL Server will do it for you based on the number of concurrent alter, drop operations and everything. It will look at the system, how it is performing, and it will drop it for you. Because when you drop it, again, like I said, it is a DDL operation. You are waiting to get a latch onto the system object page. When you have multiple of those drop operations running at the same time as you are running, then there is metadata contention. So to avoid the chance of having or forming a metadata contention, please do not explicitly drop your temporary tables. SQL Server will do the job for you. We had many stored procedures that were causing a lot of impact in performance because it was waiting to get the latch at the same time as other operations are waiting to get that page latch. So what we did is we commented out all of those drop temp tables at the end of the stored procedures in multiple stored procedures, and that helped us a lot in reducing those page latches. So you could go try it on your environment as well, but please do it on dev or test environment. You could go comment all those drop temp tables. That will help in reducing those page latches on your server, especially on your OLTP systems during business hours. You can see how many page latches are there on the system objects. So the first thing is avoid dropping the temporary tables. And the second thing is, this is an important topic. Cache your temporary tables. When I say temp tables, it also includes the temporary objects, but the most common usage of temporary objects is the tables. That's why I keep saying temp tables. All right. So you can also work on caching your temporary objects to resolve this contention. There are a few key rules that you have to follow to cache your temporary objects. First thing is, when you create your temporary table, do not alter the DDL by creating the index outside of the table definition. Once you create an index outside of this definition, then it means you are altering the DDL of the temp table. If you alter the DDL, then this temp table cannot get cached. Caching is important because imagine, for example, on a stored procedure, in one day, how many times you might be running that stored procedure. You see some executions are like 1,000 executions in 5 hours or 10,000 executions the whole day. And when they have temp tables inside them, it will help you in caching those temporary tables because you have continuous executions. So do not alter the DDL. Instead, what you could do is create the index in line with the table definition. Before closing the parenthesis, the create table parenthesis, just create the index inside of them. Any clustered index, non-clustered index, primary keys, anything. Just create them inside of the table, and that will help you cache the temp tables. And for stored procedures that have non-stop executions, like 10,000 times or many times during a day, caching those temp tables will help, because when you create a temp table, that is a DDL operation, and it needs to get a latch on the system object. By caching the temp table, you are reducing the number of latches on the system objects. So that will help improve the server level performance. So that's the reason you can try caching your temp tables. So when you create the index, create them inside, in line with the table definition. And the third part is, do not send the tables as an ad hoc statement. Create them inside the stored procedure. Like wrap it up inside a stored procedure. So that will cache the temp table. Otherwise, you won't be able to cache the table if you send it as an ad hoc statement. So these are the three things that you could do to reduce metadata contention. First thing is, avoid dropping the temp tables at the end of the stored procedure. And the other things are, try caching them, like create the index in line with the table definition. Do not alter the DDL of the temp table once you create it. And also wrap it up inside a stored procedure. So doing these things will reduce a lot of metadata contention, because we have done it on the stored procedures on a very busy OLTP systems. And I have seen 50% reduction of metadata contention by following these rules. There will still be some metadata contention existing. Making these changes will help you resolve, like for the most part, you should see some breathing app on the servers. It will resolve a lot of metadata contention, but there will still be some contention on the system objects still existing. What you could do for that is turn on memory optimized TempDB metadata feature. So this is a new feature that comes with a SQL 2019 version and above. It is not on by default. You have to turn it on. It's just it is with the server engine installed. It is just off by default. So what this feature does is, you see how we get page latches on those system objects. All those system objects will be moved to memory. So when they move to memory, now all the operations that you run will be latch free and lock free, because they're all moved to memory. They're all available right there. The operations don't need to get a latch onto those system objects. So that's what this feature does. Moves all the system objects to memory, making them latch free and lock free. So whatever remaining metadata contention you have, this feature can take care of them. So you will not see any more metadata contention that you have after you enable this feature. So this is the code that you use to turn it on. Alter server configuration, set memory optimized TempDB metadata on. Once you do this, for it to take effect, you need to restart the service, because the hackathon DLLs need to get installed. Once you restart the service, then this feature will come into effect. So these are the 12 system objects that I mentioned that will be moving to memory once you turn it on. And if you are turning it on 2019, make sure you're on one of the latest versions to make use of this feature. Right? Any questions before we go into the demo?
No questions. But I do want to make the remark that apparently after 10 years, I'm still doing it wrong.
Is it the metadata content? Oh, the queries, right? This one you mean?
The caching, so they're creating the indexes on temp tables.
Yeah.
Yeah,
Yes.
I'm still doing it wrong. So
yeah, I mean, I have been doing it wrong too. Once I learned it, I'm like, oh my goodness. Yeah. Oh, this is how you do it? Okay.
Exactly.
Yeah. So that's good. All right. No more questions. Okay, let's go ahead into the demo. So in the demo, what I'm going to be showing you is, I'm still sharing, right? Okay. In the demo, I'm going to be showing you two versions, SQL 2019 and 22. I'm going to cause contention on 2019 and also on 22 and show you how to identify and how to resolve both of these contention types on both the versions. And I will also highlight the differences, like, oh, what's the best part about 22, like what you see, what you don't see, and also about 2019. And anytime you can stop me if you have any questions. So let's start with 2019. The version that we have is 2019 CU27. And if you see, the number of processors I have are 14 on this machine. And the install is, the install gave me with 8 data files by default because I have more than 8 processors. And I haven't added anything yet. All right, and I'm using this stored procedure from Klaus Askenbrenner. It's a simple stored procedure, but I got the idea from him, so I wanted to quote his name and the website that I got from. All right, so it's just a simple one. Create a procedure and create a new temp table. It has 3 columns in it, and I'm creating the primary key inside of it. All right, and then I will be inserting 10 records into it, which is it's a SQL Server and TempDB Contention. And let me go ahead and run this stored procedure DBA test. All right, that's created. So now that I created the stored procedure, what I'm going to do is create a workload on this SQL 2019 instance using an utility called ostress utility. So what that utility does is it will stress test the server, like run it 1,000 times, run the stored procedure 1,000 times on 10 different threads or 50 threads. You can mention how many other threads or the number of executions you want. So I'm going to be stress testing this server and see what issues arise of it. And then we can go troubleshoot the issues. All right. So this will be the utility ostress.exe that I've already have it installed, and the SQL Server name. Query is execute database name, schema name, and the stored procedure name. And 50 means on 50 threads. So the number of different threads that you want to run. And 1,000 is the number of times. Or 1,000 means the number of times I want this to run, which is 1,000 in this case. And when I kick this off, I want to simultaneously check what contention or the page latches that I'm saying. So I'm going to be using this script to check contention. I actually got this script from Microsoft's website and just tweaked it a little bit for our convenience, for us to better understand. So I filtered it by page latch because that's the only thing we are interested in right now. And so what this script does is, this DM exec request is the DMV that will give you the currently active request, and DM exec SQL text, when used in conjunction with this DM exec request, it will give you what text you are running, the active text that you are running using the SQL handle. That's why we are using this DMV here. And FN page res cracker and DMDB page info are 2 new functions introduced in 2019. I just love those functions because they help you give a lot of information about the pages, the details, and it will tell you if it's PFS or GAM or SGAM page or system object page, whatever pages that you have contention on. These 2 pages, if you use them in conjunction, that will tell you everything about the pages. So that's cool, because I think back then we used to divide it by 511232, or you have to put all that math in there to find out what page it is, like if it's PFS, GAM, or SGAM. So you don't need to do that anymore with this. You could just use these 2 functions that will tell you the what page type it is. And like I said, we are just doing page latch. Don't get this confused with any other weight types. This is the only weight type we are interested in, which is about TempDB contention. If I run this now, you shouldn't see anything because we haven't kicked off anything yet. All right, now I'm going to go take this and run it on this RML utility. 2019, this is the stored procedure. Okay. All right, run this. This is running worker threads created, beginning execution. Okay, let's go run this. All right, we do see a lot. Okay, page latch, weight type. Okay, good. This is TempDB database ID 2, and the page is on system allocation units. So we see page latches on TempDB on system pages, which is nothing but metadata pages. So we know this is metadata contention. I'm going to scroll all the way to the right. All right, metadata contention. And I'm also going to check if there's anything else. So I'm going to scroll all the way to the end. All right, all we see now is metadata contention. And how do we resolve metadata contention? We have to make sure our query looks good, the stored procedure that we have. We are creating the primary key inside, which is good. We are not altering the DDL outside of the temp table. So that's good. And we are also wrapping the temp table inside the stored procedure. So that is also good. We are helping it cache the temp table. And we are not dropping the temp table here. Good. We are following all the good rules for caching the temp table and also helping with metadata contention. So that part is good. We have a new feature that I just talked about that we could enable to get rid of this metadata contention. So let's go ahead and try it out if that helps. So if you see the server property, it will show 0 because that's the default value that it comes with. It's disabled by default. I'm going to go ahead and enable this memory optimized TempDB metadata. I'm on 2019, right? Okay. I'm enabling this. And for this to take effect, I need to restart the service. And please don't restart it like me from SSMS. It's just a sandbox, so I'm doing it from here. But if you're on your production server, please do it on your log into the RDP to the node and do it from the cluster manager if you have clustered instances, or from the configuration manager if you have standalone instances. So now that I have restarted, if you see here, this should be 1. So that's good. It's enabled. And also, once this is enabled, we should see 12 objects, 12 system objects moved to memory. And how many do we have here? Yes, we do see 12. That's good. And if you see, this is allocation units is one of those tables that there were page latches on. And if you see in the one that we just enabled the feature, you will see sys allocation units here. That means this object is also moved from the normal, from the buffers or the disk or the buffers to another part in the memory where it can be latch free and lock free. So the next time when we run this script, you will not see this page latches on the system object anymore because we have enabled this feature which has moved these tables to memory. So that is why we enable this feature, to reduce those page latches on these system objects. And you might be thinking, okay, now that you moved the system objects to memory, how much memory is it occupying? Let's find that out. And using this is DMOS memory clerks that will give you the information about how many pages or how much memory it's actually occupying in the memory. And we are using DBID2. Like I said, 2 is always for TempDB in any SQL Server instance. Let's go ahead and check it. Okay, it's just 81 pages in Mac, so that's nothing. And that is also helpful for us. So we turned on this feature now. What I'm going to do now is, okay, so this is complete. So the only change that I did is enabled that metadata TempDB feature. We are going to go ahead and run it. The same workload, everything the same, no changes. All right, let's go ahead and run this. Worker threads created. Let's run this now. Okay. Well, we see page latch on CAM page. Okay. So we are not seeing system objects here anymore. I'm scrolling down. Okay. We don't see any system objects. It's all about GAM page. So one thing for sure we could tell is we don't see page latches on system objects. That means we don't see metadata contention anymore. That's good. No metadata contention. But we have a new problem. That's allocation contention, because now you are seeing page latches on GAM page. You know that when you see PFS GAM as GAM here, then it is allocation contention. All right. So to resolve this allocation contention, we need more PFS GAM and SGAM pages. And how do we get more of those? Add more data files. So let's go see how many we need to add. So as of now, I have 8. Before adding any data files, what I want to do is bring up perfmon, and I want to see how many page latches we have right now. And I'm going to add the data files and want to see how many page latches got reduced. So before adding anything, let me just turn this on, grab the spike, what it is right now. All right. No changes as of now. I'm just running the workload. to get the number of page latch weights. Okay, so right now, if you see, we are at, let me get on this one, page latches. If you see 9,000, 12,000 page latches, if you see this number, it can give you where it is, 13,000. All right, so it's just going high up. It's still in 13,000. Okay, it's about to finish. Okay, it finished. Now it will go down. That's good. Okay, good. It has gone down. So here it's just with 8 data files. We haven't added any at all yet. And you see the maximum we had 13,000. All right. So what I want to do now is add 4 data files of equal size. 9, 10, 11, 12. That's good. Let's check. We should have 12 data files. That's good. What I'm going to do now is start perform and kick off the workload again. So the same workload, the only difference now is I added another 4 set of data files. Okay, so the red line is the page latches. If you see the red line, that's the page latches that I'm pointing at. So if you see the maximum it went is maybe around 6,000. It didn't go higher than 6,000. Let's see. Okay, so the workload finished. Okay. So if you see, the green is the batch request or the throughput, which is this workload that I'm running on the command line, is the green line. The red line is the page latches. So earlier when we had 8 data files, you see how the page latches spiked up close to 13,000. After we added 4 data files, you see how the page latches are only 50% of it. 50% of it is gone just by adding 4 data files. You see if the spike is maybe, let's do 6,000. Earlier it was 13,000. So that's like even more than 50%. So that's a very big improvement. What I want to do now is add another 4 data files and see if the spike goes down even more. It may or may not. Let's go and check that out. All right. So I'm going to add 13, 14, 15, and 16. Okay. Now we have 16 data files. That's good. Okay. And let me bring this up. I'm going to start this and then run the same workload again. Okay. We have another set of 4 data files. Let's see where the red line goes. Okay. It's still the same. Okay. Not a big difference. No difference at all. It's the same. Okay. The red line is still there. Okay. Maybe a little bit here and there down, but not an impact, right? Okay, so this is the thing I wanted to show. Here we have a clear graph now. So this is on 2019 version. You see how the spike is before adding any data files. After we added 4 data files, there is a very big improvement. Again, we added another 4 data files. There's absolutely nothing. It's still the same. So how do you know when do you add data files and how many do you add and where to stop adding data files? Bring up perfmon. Whenever you have this allocation contention, before adding the data files, bring up perfmon, grab the spike, add data files. Now again, get a spike. Get the graph. Now you will see, oh, okay, so I've made this difference. This is good. Let me go ahead and add another 4 data files. Now you see, okay, I haven't made any difference now. I'm not going to add any more data files. It's not going to help. So that helps you decide how and when to add and when to stop adding the data files. All right. And I want to make this clear that on versions 2019 and older, you won't be able to completely get rid of this allocation contention. You will be able to resolve it to some extent, 50% in some cases, 80 to 90% I've seen in some cases, but getting rid of it absolutely has not been possible. You will still see a little bit of page latches here and there, but that's fine because you have more than 50% of improvement on your server. That's a big win. So don't worry about it. But the point that I want to make clear is on 2019 and older versions, you should be able to mitigate it to some extent, but not completely get rid of it. And like all of you, I'm not a big fan of perfmon either. I don't use it in my everyday work. It's just for this contention or for things that help me. I use perfmon, and it's not like my everyday thing. I just use perf-mon, so it gives me that clear graph of, oh, okay, now I can add files. Okay, now I should stop adding. It's not helping. To help you make those informed decisions, you can use perf-mon and check things out. All right. So what we did now until now is we caused contention on 2019. We saw metadata contention. We made sure our query looks good, caching the temp table and not dropping the temp table. And we enabled the metadata feature that moved the objects to memory, and there were no latches at all, and that got rid of metadata contention. The next thing we saw is allocation contention, which is on PFS, GAM, and SCAM pages. And to resolve that, we added 4 data files. There was 50% of reduction in the page latches. Again, we added another 4 data files, but that didn't help much. So on 2019, we saw both of these contention types, and we were able to mitigate the allocation contention to some extent and resolve metadata contention. Now, we are going to do the same thing in SQL 22 version. Exactly the same workload, same store procedure, absolutely the same scripts. Everything is the same. It's just the version is 22. So let's go ahead to 22. But before going on to 22, any questions on 2019?
No questions in the chat window.
Okay, cool. So this is on 22, CU13, and I have 14 processors. And there should be 8 data files that came with the install. And I'm using the same store procedure that has 3 columns in the temp table, and I'm inserting records into this. All right, everything is the same. And I will be using this same OSTress utility. The only change is this version name. Before that, I just want to keep my contention script ready. That's on 22. And if you see this, the same thing that we just talked about. We have nothing running because it's on 22. We haven't kicked off anything yet. All right. So let me go ahead and run this on 22. I'm using this RML command line. Let me run this. Worker that's created. Good. Let's check the contention. Okay. I guess it will look familiar to you now because we have seen page latches on system objects. We know that is metadata contention. Let's just scroll through. Okay, all metadata, and I'm going to scroll all the way to the end. Okay, it's all metadata contention. We already know that our query looks good. We made sure to cache the temp table and everything. But let's check if our metadata feature, the TempDB metadata feature, is not enabled yet because it's disabled by default. We did enable it on 2019 and it helped. So on 22, we are going to do the same thing. And I am going to enable this now here. And this needs a restart. And if you were to enable on your production or non-production service, make sure you do it on both active and passive nodes, or on both primary and secondary nodes, because when you do the failover, you want it to be consistent across all the nodes. All right. And now this should be enabled on 22. That's good. And then we are validating here. 12 objects are moved. That's good. And let's see how much memory. 84 meg. So that's nothing. Okay. So that's good as well. Now let's kick off the same workload and see how it behaves. So as of now, we have seen metadata contention on 22, and we enabled the feature, the metadata, TempDB metadata feature. And let's kick off the workload and see how it behaves. So it's running the same workload. All right, I don't see anything. Okay, so that's good. Metadata contention is resolved. We were able to get rid of it. Good thing. What about allocation contention? We only have 8 data files, and I haven't added any data files yet, but still we don't see allocation contention. But before jumping into that conclusion, what I want to do is bring up perf-mon for 22, and I want to see maybe there are some page latches that I'm not catching in SSMS. We could catch them easily here if there are any. So what I want to do is kick off this workload again. I'll start this perf-mon here and kick off this workload again and see if there are any red lines here at all, because red is our page latch weights. I want to see if there's anything. As of now, it's 0. You see all the values here, 0. Okay, it's just 0. All I have is the throughput that the workload is running. Absolutely no page latches. Okay, it finished. Okay, you see absolutely no page latches. So that's the best part of 22. Allocation contention, where it is all about the data files. That issue does not exist on 22 anymore because it comes resolved with the engine itself. You don't have to manually take any action to add any data files. That's the best part of 22. But you still have metadata contention. In 22 also, you still have metadata contention, which you need to resolve either by caching the temporary objects or by avoiding dropping the temporary objects. And also you can make use of the feature here, TempDB metadata feature we just used. So what we saw on 22 is we caused contention. We saw only metadata contention. We didn't see allocation contention. Metadata contention we resolved by enabling this feature. Allocation contention on 22 does not exist. It comes resolved within the box. You don't have to manually take any action. So that brings us to the end of the demo. We saw two versions, 19 and 22. 19, we had both types of contention and we addressed it. On 22, we had only one type of contention, that is metadata contention. All right. Any questions?
No questions.
Good. All right. Okay. I want to discuss some of the common mistakes that we have. I see a lot of things, whenever there is contention on TempDB, the first thing people say is, that was including me a few years ago. Oh, add data files. No, it is not always about data files. Please do remember the part that when you have page latches on PFS, GAM, SGAM, add data files. When you have page latches on anything else apart from PFS, GAM, SGAM, adding data files is not going to help. So please remember the part that if you see page latches or TempDB contention, page latches on TempDB is nothing but TempDB contention. So when you have that, it's not always about data files. And the second thing is, I see this everywhere on Stack Overflow or any of the online websites, and people are always talking about, oh, 22, TempDB contention is resolved. You don't have to do anything. No, that's not true. And also there are people complaining about, oh, I thought 22 had TempDB contention resolved. I still see contention. Of course, you will still see contention, because on 22, only the allocation part is resolved. The allocation contention, where we add data files, that part is resolved. You don't have to add data files. But the metadata contention on 22 still exists. Metadata contention still exists, and I keep repeating it everywhere. So there is still metadata contention on TempDB in 22, and you have to manually address it. It is not resolved by default. And the third one is, this is not a mistake, this is more like a caution. On 2019, this new feature that I talked about, the in-memory TempDB metadata feature, does not work at its optimal level. It is known to cause some unexpected server restarts during the middle of the days because it does not do the cleanup job very well. So it does cause some unexpected server restarts. So I do not recommend enabling this feature on 2019. On 22, it does a good job. On 2019, I do not recommend enabling it, but if you still want to enable it, please do a very thorough testing on your lower regions, and then you can check on if you want to enable it or not. But the errors that people face and Microsoft has provided resolutions with, I have tagged the website here if you want to take a look at what are the errors and how to resolve them in case you're running into them. All right. And the final part, I know I've given a lot of information this past hour, even if you didn't listen to any of that, or if it's hard to reach in all of that, just focus on this flowchart, have it handy. You should be able to get the whole essence of this session. All right. The first thing, do you see page latch? Yes. Do you see it on TempDB? Yes, that's very important. If you see it on other databases, then things vary that what action you have to take, but make sure whatever you're seeing is on TempDB, then all of this apply. All right. You see it on TempDB? Yes. Do you see it on PFS, GAM, SGAM pages? Yes. Then add 4 data files or 8 data files of equal size. Again, check for contention. Do you still see contention? Yes. Now add another 4 or 8 data files of equal size and then go in the loop. Again, check for contention. If you still see, then keep adding another 4 data files. All right, so this is the direction you take when you see page latches on PFS, GAM, SGAM pages. But instead of PFS, GAM, SGAM, if you see page latches on these system objects here, then the direction you have to take is cache your temp tables and avoid dropping your temp tables. And if you still see contention, now enable that in-memory TempDB metadata feature in 22. All right. So this part, the green part, is the allocation contention part that was resolved in 22. The lower part here, that is not resolved by default. You have to manually address it. That's the metadata contention part. The one below the green box is the metadata contention, and you have to manually address and resolve it. So that's the important thing I wanted to mention. You can have this flowchart handy, and whenever you run into TempDB contention issues, just take a look and see if it's PFS, GAM, SGAM, then go in this direction. If it's system objects, then go in the other direction here that I've provided. All right. So the one in the green box, I repeat, that's the only one resolved by default. All the other parts here, it's not resolved by default. You have to manually address and resolve them. All right. I really hope this helps. All right. Summary. 2 types of contention we discussed. The first one is the allocation contention. When you see them on PFS, GAM, SGAM pages, then you know it is allocation contention, especially the page latches when you see them on PFS, GAM, SGAM pages. What you do is, if you're on 2019 and older, add multiple data files in sets of 4 of the same size. If you're on 22, you don't have to take any action because you won't see this contention. And if you're facing a lot of this allocation contention, I recommend upgrading to 22. And also, I want to remind you, on versions 2019 and older, you won't be able to completely get rid of it, but you should be able to mitigate it to a good extent. All right. And metadata contention. When you see page latches on system object pages, then you know it's metadata contention. There are some rules for caching that will help you reduce this contention. And also you can stop dropping the temporary objects at the end of your stored procedures. And you can take advantage of that in-memory TempDB metadata feature. Like I said, remember the caution, 2019, it causes some restarts. On 22, it has been performing well. And this metadata contention, you have to manually address and resolve even in 22. All right. So these are the 2 types of contention we discussed. And now at the end of the session, now you know how we addressed the slowness that are caused by page latches. We have identified the slowness and also we addressed it either by making use of that new metadata feature or by caching the temporary objects and avoiding dropping the temporary objects. Doing those things, you reduce a lot of page latches that will help you address the slowness in the system. Not just that, the concurrent transactions, we were able to manage them by adding more number of data files. Now all those transactions will spread across the data files. That's how you address all the concurrent transactions in the server. All right. I hope this is very helpful to you. The time and effort that you have put in to be here today. Thank you everyone so much. I hope this adds value to your whatever issues you have at work with the TempDB. I really hope this helps.